Hello viewers, welcome to this video lecture series on analysis and design of algorithms. Today's topic of discussion is on a sorting algorithm, and the name of the algorithm is selection sort. For this algorithm, I shall be explaining the algorithm code as well. I'll trace the algorithm with an example. So this algorithm makes use of the brute force approach. So brute force approach, as I already stated in my previous videos, that it is going to make all the options exhaustively. So let us see this pseudocode first, then I shall trace the same with an example. Normally for any algorithm, as I already said, first you write one comment line wherein you mention what is this algorithm. So it sorts a given array by selection sort. Then in the second comment line, what input you are going to give to this algorithm, and in the third comment line, what output are you expecting from this algorithm. These three are also mandatory apart from the lines of code. So you write these, then you come to the logic here. So it makes use of the two for loop here, the outer for loop and the inner for loop. The outer for loop keeps track of every element in the array, and the inner for loop keeps track of all the comparisons for that element. Suppose if these are the elements 22, 9, 6, 12 and 8, 5 elements. If there are 5 elements, that means n equal to 5, and the number of passes required for sorting will be n minus 1, that is 4 passes. At the end of first pass, the minimum element is here, the 6, that is the element 6 will come in the first position. At the end of the second pass, the second element, that is 8, will come in the second position. At the end of the third pass, 9 will occupy in its position, and at the end of the fourth pass, the element 12 will take its place. At the end of the fourth pass, you will get like this. So only one element is remaining. By default, it will occupy its position. This is the situation at the end of the first pass, second pass, third pass and fourth pass. So we shall see the same thing. So here I am just writing at the end of each pass, but actually in each pass itself there will be number of comparisons done. So how many number of comparisons are done and how many number of times the minimum value get updated, all that will get included in first pass. Then similarly second pass, third pass, fourth pass. So these things I shall explain to you here. So the logic is like this. You have two loops here. The first for loop is going to keep track of every element, whatever are the elements. Then for each element, whatever are the number of comparisons done, that will be taken care by the inner for loop. And we are making use of a variable min, okay, which will always store what the location where the minimum element is present. So initially minimum value will be what the location number 0, that is index 0. We assume that at index 0 is the minimum element present. Later on, once the comparisons are done, the minimum value gets updated. So it always compares whatever is the next element in the array with the minimum element. If it is true, then it will update the minimum value, okay. It will update the minimum value. Like this, it will carry out for all the number of comparisons until the J loop gets over. You can use the opening and flowering brace to indicate the scopes for all these for loops so that it will be more clear. See, if and min, these two are applicable for the inner for loop. Okay, if you want, you can place the scope for this for loop also. These two statements are inside the for loop, inside the inner for loop. That is, it is going to work for j equal to 1, j equal to 2, j equal to 3, j equal to 4. Once it completes up till 4, then it will try to swap this. So let me show you the working of this with an example. 5 elements here and the index numbers I'll be writing here on the top. Fine. And in the first pass, I will operate from 0, I equal to 0. And I will function for what? J equal to 1, j equal to 2, j equal to 3 and j equal to 4. So 4 comparisons you need to carry out in the first pass. And as per the algorithm, the minimum, okay, you have to keep track of the location number where the minimum element is stored. The algorithm first assumes that the very first element that is present is minimum. So the location for this element is 0. So the element, this minimum is what? 0. What is the element at a minimum? What is the element? Element is 22. So this is your initial assumptions. Now with the initial assumptions, your I value is here, your j pointer, your I pointer is here and your j pointer is here. So how you are going to carry out? First you will compare a of j with a of I. That is, you are comparing here. As per the algorithm, you can see if a of j is less than a of minimum. A of minimum is how much? 22. A of j is how much? 9. So you are trying to whether 9 is less than 22. Yes, it is true. If it is true, you can see here the minimum value should get updated. What is that minimum of getting updated? Because now the minimum is, you have the minimum element is 9, the location, the corresponding location number is 1. So as per this, you have to update the location number 1. Fine, just, and also we'll see what is the element that is present at the location. So now your A minimum is how much? 9. The element is 9. Next, now J pointer. So this is happening in the very first comparison. You had compared this 22 with 9. Next time what you are going to do is 22, 9, 6, 12 and 8. Now you will compare. A minimum is how much now? 9. And this J pointer will point to this location. Now A of J is compared with A of minimum. So you are comparing these two elements now. Once you try to compare, what is that? A of J is 6. 6 less than A of minimum is how much now? 9. Yes, it is true. If it is true, then update the corresponding location number. Now your current minimum location number is 2 and the element is what? 6. A minimum is 6. Next, J pointer. J will get incremented by 1. So now J is here. J is pointing to 3. You have completed J equal to 1, J equal to 2. Now J is pointing to 3. A of J is how much? 12. Whether 12 is less than A of minimum. A of minimum is how much? 6. No, it is not true. It is false. Okay, if it is false, you don't update anything here. Simply move the J pointer. Simply increase the J pointer. So your next, this one will be what? J will be pointing to this. Fine. Now once J is pointing here, A of J is how much? 8. What is the current minimum element? 6. Whether 8 is less than 6? No, it is not. So it is false. If it is false, then you don't have to update anything to the minimum variable. So also the J for loop ends here. This ends the number of comparisons for that particular value of I. Now your job is to execute this statement. The control will come out from the inner for loop and it will execute this statement. What is this statement? Swap A of I with A of minimum. A of I is here, okay, which was here, with A of minimum. A of minimum is your 6, this one. So these two elements will get swapped. I'll just show you the difference here. This was the comparisons. Okay, this was the comparison. 9 with 6, then 12 with 6. This was the comparison. Then after that 8 with 6 also was the comparison. Okay, then comes what? The swapping. So you are going to write here 9, 6, 12 and 8. You have to swap A of I and A of minimum. A of I is 22, A of minimum is this one. So this will be your swapping. So for swapping, I'll just write here. So this particular swapping has happened once it has compared all the elements. Okay, that means whatever were the number of comparisons required here for the first pass, that is for I equal to 0, J equal to 1, J equal to 2, J equal to 3, J equal to 4. All that you can see here. J is pointing to 1, J equal to 2, J equal to 3 and this one is J equal to 4. So once you swap this, you will get 6, 9, 22, 12 and 8. This is the end of the first pass. So here you have swapped also. That statement I'll write down. Swap A of I and A of minimum. This completes the first pass. Now let us go for the second pass, wherein now the outer for loop I will increment by 1, I equal to 1. Now you have to check what for J equal to 2. That means you have to carry out these many comparisons. Fine. Now we'll start again freshly. 6, 9, 22, 12 and 8. I is what? Now this one more thing you have to read in the second pass. I is operating from 1. So 0, 1, 2, 3 and 4. So this element is already sorted. Now I is pointing here, J is pointing here. Fine. So once again, what the minimum is always set to whatever is the first element, the index number. Now in this case, in the second pass, minimum is initialized to 1. Next comes, you have to start with J equal to 2. J equal to 2, what is the comparison? You have to carry out the comparison. So A of J is how much? 22. Whether 22 is less than 9? No, it is not less than 9. It is false. then don't update the minimum. Still we are assuming that this number itself is the minimum. Increase the j value now. Okay, now j comes over here. Fine. So first time what we did in the first comparison was this one. This was your first comparison. Now we are here. So we'll compare now. So now j gets incremented by 1. So j is pointing here. Now a of j is how much? 12. Whether 12 is less than a of minimum. A of minimum is how much? Let me write a of minimum also. So 9. 12 is less than 9? No, it is not less than 9. So you have compared these two. 12 is less than 9? No, false. If it is false, don't update anything for the minimum. Keep it as it is. Increment the j pointer by 1. So your now j will be pointing to 12 and 8. So j will be pointing here. Now at this point you have to once again compare with what? This one. Your a of j is how much? 8. 8 is less than a minimum. A minimum is 9. Yes, it is true. If it is true, then update now. What is the minimum? What is the index value for this element? It is 4. So your minimum is what now? 4. And what is the element? Element at location 4 is 8. Fine. So after this, inner for loop will end here, and the statement that is present here, that is the swap statement, will get executed. So which two elements will get swapped now? Presently a of minimum is, we have updated now, 8. 8 with 9. So 8 will come over here, 22, 12, and what is this? The element is 9. So this element which was not getting included here will add in. 6 is the element which is in the sorted list. Now let me include here. So now at the end of the second pass, we got these two elements sorted, 6 and 8. Fine. So you can check here in the second pass also, what is that? J started with 2, 3 and 4. J equal to 2, J equal to 3 and J equal to 4. So 3 comparisons are done. Here 1, 2, 3, 4. 4 comparisons are done. So this completes what? The end of the second pass. Now outer for loop, I gets incremented by 1, I equal to 2. So now our elements are which one? 22, 12 and 9. So these two are sorted. Let me include it later. So your I point, these two are sorted already, 6 and 8. So let me write the index. So now your I is here and J is here. So I initially minimum is what? The location number of I. Location number here is 2. So we are saying that whatever element is present at the location number 2 is the minimum. And what is the element? Element is a of minimum is what? 22. Okay, this is what. Now a of j. So this inner for loop will start j. A of j is how much? 12. For I equal to 2, j will start working from j equal to 3 and j equal to 4. Two comparisons are there. So let us start. A of j is how much? 12. 12 is less than a minimum. A minimum is how much? 22. Yes, it is true. If it is true, what is that you have to do? You will update the minimum value. What is the new minimum value? Now 12 is the minimum, so its location number is 3. So now minimum is 3. Next, if this is minimum, location number 3 is assigned to minimum, the corresponding element is what? 12. Okay, that also I'll write down. Increment the j value by 1. So your j is pointing here. J is pointing here. A of j is 9. Whether 9 is less than a of minimum. A of minimum is 12. Yes, it is true. If it is true, update the location number. Location number is here 4. So we'll write here 4 and the new minimum value is 9. Fine. So now once you do this, moreover, now all the elements gets completed here. There is no further element for j to get increased. So j for loop will also end here. Then the control will come out from this and it will carry out the swap statement. Swap is with a of I and a of minimum. A of minimum currently is how much? 9. So 9 will come over here. So this is the swap being taken. So this will swap. So 9 will come over here. 12, 22. So I'll show the comparison also. First time this was compared 12 and 22. Second time 9 and 12. Okay. Now after that, once we found that 9 is the minimum element, then we need to swap with a of I. A of I is 22. So 9 and 22 will get swapped and your new array will be, so 9 will come over here. Let me put the remaining element also, 6 and 8. Fine. So now this is the status at the end of the, so here you have done the swapping. Swap a of I and a of minimum. To do now I equal to 3. This will be in the fourth pass and j will work from only, j value will be only 4. So it will have only one comparison. Let us see that. So presently your sorted elements are 6, 8, 9. Okay, now I is here pointing to here and 22, j is pointing here. What is the, so we'll start as per the algorithm. Minimum has to be assigned. Minimum is initialized to what? The location number. So location number here is 3, minimum is 3. A minimum is how much? A minimum is 12. A minimum is how much? Minimum is 3 and A minimum is 12. Fine. Now you are taking A of j. A of j is 22. Whether 22 is less than 12? No, it is not true. So it is false. If it is false, no need to update the value for the minimum also. The inner for loop will end here. If it is true, you are updating the value for minimum. Now if it is false, you will not update the value for the minimum. It will come out of that loop and whatever numbers we get at the end of the fourth pass is the sorted array. 6, 8, 9, 12, 22. Fine. So this is your sorted array. For this algorithm in the tracing we have seen that yes, I will start from 0 and it will have j equal to 1 to 4, and in the first pass what is that we have seen? 1, 2, 3, 4 comparisons are done. 4 comparisons are done and one swapping is taking place, and in the second pass 1, 2, 3, 3 comparisons are done and there is one swap happening, and in the third pass we have seen that 1 and 2, 2 comparisons are done and one swap taking place, and in the fourth comparison it is seen that only one comparison is done and there is no swapping taking place. For each pass I have shown you how to update the value for the minimum variable. Look here, here, here and here. There is one more logic for this selection sort algorithm. In that logic, what exactly happens is simply whatever is the first element, it gets compared with the adjacent element. If the adjacent element is smaller, immediately it will get swapped. Fine. Like this, it is going to compare every element with its adjacent element in the array, and whenever it finds the adjacent element smaller, it swaps. So it is not making use of any variable minimum here to keep track of the location of that minimum element. This is the pseudocode for the algorithm. Okay, so I'm just writing your algorithm too. You can definitely try to check in the lab. One time you carry out the execution of the program using this logic. Okay. Second time you carry out the execution of this program with this logic, and also for this second logic, how the tracing can be done immediately in the same video. I'll post it at the end. I'll carry out on a sheet of paper and I shall post it at the end. You can compare it. You can always compare this tracing of algorithm 1 with the tracing of algorithm 2 and check there also how many number of swaps are taking place in each pass, and then you try to execute in the lab also the code for both these algorithms and try to see what will be the running time for each of these. It will be a case study for you to compare the time efficiencies for both of these algorithms. Definitely with a smaller value of n, you may not be able to see the difference. Take a larger value of n and then try to see the time efficiency in each of these algorithms. This is just for comparison purpose. I have given the second logic, but you are going to use only the first logic in the test or examination. This is the logic that is mentioned in most of the standard textbooks. But for your curiosity, you can try to compare these two algorithms. And also, whenever we talk about an algorithm, we always have to look into its time complexity as well as space complexity. So just see what space complexity difference also you are going to get in this algorithm. Moreover, you can check here the second algorithm is not making use of any extra variable. The first algorithm is making use of an extra variable min to store or to update the location of the minimum element. How do you start analyzing this algorithm. Basically you want to calculate the time efficiency, so we'll write T of n equal to, just see here the outer for loop for I equal to 0 to n minus 2. So that part we need to write, yes, for I equal to 0 to n minus 2. What about the inner? In for loop it will run from j equal to I plus 1 to n minus 1. Fine, to n minus 1. And inside this is your basic operation. So this is the operation, one important operation, a of j less than or equal to a of minimum, that will run definitely based on the input value. So this statement will get executed based on the value of the input. So now we are writing here, this one is for that statement, the basic operation is what? A of j less than a of minimum. Now what you have to do is, in the second step, you just carry out like this, outer for loop, fine. Further simplification, the upper limit is n minus 1, minus of what? Lower limit is I plus 1, and you have this one, okay, we'll bring it here, this one as it is. Further simplification, this will be I equal to 0 to n minus 2, n minus 1 minus I minus 1 plus 1, fine. Then this minus 1 plus 1 will cancel. So you will have only summation I equal to 0 to n minus 2, n minus 1 minus I. Now for this I, you have to substitute what? The values from substituting the value 0 and n minus 2 in this equation, you will get n into n minus 1 by 2. Further, if you simplify, you will get n square by n by 2. Now what is the higher order term here? N square. So the time efficiency for this algorithm is theta of n square. For average case, for best case, and for the worst case. The performance in all these three cases for selection sort is theta of n square, theta of n square, theta of n square. See, average case and worst case we can definitely understand. Best case is what? Best case is the elements are already sorted. Suppose if you are given an array which is already in this sorted form and you are trying to apply the selection sort algorithm here in order to sort the elements. Since the elements are already sorted, what will happen? The thing is, though elements are sorted, the algorithm will run. Basic operation will also run. So that's it in this session. Hope you find this session useful. If you find it useful, please like, share and subscribe to my channel. Thank you. Bye bye and take care.